Today's daily code problem of the day is the minimum number of removals to make a mountain array number 1671. For this problem, we want to make a mountain array. So if we look down at example 1, a mountain array simply means that there's a 1, so a small number, a big number, and then a small number. So it peaks. We want it to go from small to big to small again. If we look at example 2, we have this array of numbers, and to make it a mountain, we would have 1, 5, 6, 3, 1. So again, it peaks at 6. 5 is less than 6, but greater than 1. 1 is strictly less than 5. 3 is less than 6, but greater than 1. And 1 is strictly less than 3. So for a mountain array, it has to come to a peak in the sense of values. So we are going to have a strictly increasing sequence up to a peak element, and a strictly decreasing sequence after that peak element. So we can remove elements to create this, but we need to minimize the number of removals that we can make. So how are we going to approach this? We are going to use dynamic programming to find two main things for each element in the array. One, we're going to find the longest incrementing subsequence ending at each element, and then we're going to find the longest decreasing subsequence starting at each element. So by combining these two values, we'll be able to figure out the minimum number of elements we need to remove. So let's say at 2, the maximum increasing we can make is 1. At 1, the maximum increasing we can make is 1 because 2 is greater than it. Maximum increasing at this one is, again, 1 because 1 is not less than, it's equal to. So when we get to 5, the longest increasing we can make is 2. So let's go ahead and let's dive into the code here. First thing we're going to do is we're going to create a value to represent the length of our array, and then we are going to create a longest increasing sequence and a longest decreasing sequence array to store our values. So we'll have an int n will be equal to our nums.length. We'll have our integer array longest increasing sequence length, new integer array. We'll have an integer array longest decreasing sequence length, which will be equal to a new integer array. And these are of both length n, because that is the max length of nums. And then we're going to fill both of these with 1s, because starting at each position, the max that we can go is 1 at that position. So arrays dot fill lis length with 1, and arrays fill LDS length with 1. So we're initializing our arrays, and these are our dynamic programming arrays. We're initializing them all at 1 because at 2 the longest is 1, at 1 the longest is 1, so on and so forth. Next, we're going to calculate our longest increasing subsequence for each element. So we're going to have a nested loop. So for int I is equal to 0 as long as I is less than n, I plus plus. For int j is equal to 0. Sorry, j is going to be equal to I minus 1. J is going to be greater than or equal to 0. And j is going to subtract 1. So this is going to simply check if the number behind it is smaller. So if nums of I is greater than nums of j, then it's valid. So our longest increasing subsequence length of I is going to be equal to, what on earth happened here? Of I is going to be equal to math.max of our longest increasing subsequence array length of I. So whatever the previous value was, initially it's going to be 0, and the lis length of j plus 1, because that is our new subsequence, j plus 1, because we're starting at j and I is bigger. So that calculates our longest increasing subsequence by checking all the previous elements j up to I. Then, if nums of I is greater than nums of j, we will extend our subsequence, ending at j. Next, we're going to calculate our longest decreasing sequence. So for int I is equal to 0, as long as I is less than, I is going to be equal to n minus 1, because we're starting at the end. As long as I is greater than or equal to 0, I will decrease, It's going to be a nested loop, so for int j is going to be equal to I plus 1, because we're checking previous elements. As long as j is less than n, j is going to increase. So our longest decreasing sequence length of I is going to be equal to math.max of LDS length of I, LDS length of j plus 1. So we're going to iterate from the end of the array to the beginning. For each element I, we check future elements j after I. And if nums of I is greater than nums of j, which we almost forgot to do, if nums of I is greater than nums of j, so we're going to iterate from the end of the array to the beginning. For each I, we check all future elements j after I. If nums of I is greater than nums of j, then nums of I can start a decreased subsequence from j. We update LDS length to reflect the longest decreasing sequence we can generate starting at I. Boom. So we calculated using our dynamic programming arrays. Now that we have our longest increasing subsequence and our longest decreasing subsequence lengths for each element, we can calculate the minimum number of removals to form the mountain array. So we're going to have int min remove. It's going to be equal to integer dot max values, so that way any value is smaller than that. And for integer I is equal to 0, as long as I is less than big N, I plus plus. So as we increment through this, we are going to check if our LIS length of I is greater than 1 and LDS length of I is greater than 1, then we can increment our min removal. So min removal is going to be equal to math.minimum of min removal and n minus list length of I minus LDS length of I plus 1. So that's our formula to calculate how many items we have to delete to get the mountain array. After that, we can simply return our min removal, and that's it. So if we run this, passes our test cases, and if we submit it, passes all solutions. Thank you for watching, and don't forget to follow for more daily LeetCode solutions. And let me know if you'd like a Discord where I can teach you more on how to solve LeetCodes, all the resources I use to solve LeetCodes, and just my strategy when I approach these LeetCode problems. Thank you, and see you tomorrow.